In this example, we're going to find a possible formula for a rational function when given its graph. So before we get started, the key that we want to look at is that we want to look at zeros of the function and think about what that means in terms of the formula. So the key property is that anytime we take 0 and we divide it by a number, so let's say we divided it by 3, we would get 0. So anytime we see a 0 on this function, which I've got a couple of them here, I've got one here and I've got one here. So I have a 0 of -2 and a 0 of 3. That's going to correspond to a factor in my numerator. Now, in the same way that we looked at polynomials, the multiplicity of that 0 is going to relate to an exponent on the factors that correspond. So we'll get into that. The other thing that we want to keep in mind is that anytime we take a number and divide it by 0, so again, I'm just arbitrarily picking 3, that's going to be undefined. And so anytime we see a vertical asymptote, and here I've got x equals -5 shown, and I've got x equals 4 shown. I have two vertical asymptotes. Those are going to correspond to factors that are in my denominator. The last thing that we'll look at is the long-run behavior of this graph, and we'll use that horizontal asymptote to help us with that. There are a couple other techniques we can do with that as well. So to get started, let's put all of this information into a table. And so we need to identify the zeros and the vertical asymptotes. And I'll put those in the same place. And we're going to want to look at the multiplicity. And then after that, we want to state what factor then needs to be in our rational function. And the last thing we're going to do is then state whether or not that factor goes in the numerator of our function or the denominator. And I'll abbreviate denominator there. Okay, so for the zeros, we saw that we had a 0 at -2. So there's a 0 of -2. And we also had a 0 of 3. Okay. And the multiplicity, so I highlighted the behavior around -2, and we can see that that function hits that x-axis and then comes back up. So that's going to result in even multiplicity, and we'll assume 2. We might need to change that to a higher power in certain instances, but for here we'll just assume it's 2 until we look at it further. And then for the next 0, we can see that it crosses that x-axis, so that's going to be odd. And so we'll assume that's 1. Okay, and so then what we look at is the factor. So we have a 0 of -2, so we need a factor of x minus a -2, which will be x plus 2. And that exponent is going to be squared. For the 0 of 3, we're going to have a factor of x minus 3, and that exponent will just be 1, based on the fact that that has odd multiplicity. And then both of these, because they're zeros, are going to go in the numerator. Okay, now we'll take the vertical asymptotes and we'll do something similar. So we see that we have a vertical asymptote of x equals -5, and we have a vertical asymptote of x equals 4. Now, this multiplicity is a little bit trickier. This multiplicity, it's helpful to think about, let me draw y equals, just a very rough sketch of y equals 1 over x. Here's x, here's y. If we think about 1 over x, it goes like this, and then it flips over like this. And if we draw a really rough sketch of 1 over x squared, okay, so the reason I'm showing these is that these are helpful in determining whether or not the factors resulting from these vertical asymptotes are going to occur an even number of times or an odd number of times. What we're looking at is whether or not both arrows go up, both arrows go down. So that would be looking at even, or whether they switch. So we can see with this one that from the right it goes up, and then from the left it goes down. With y equals 1 over x squared, both arrows are heading up, and those each have a vertical asymptote of x equals 0. So we're looking then at what happens at those endpoints. And so when I look at the vertical asymptote of x equals -5, I can see that both of these arrows are pointing up. So that's going to tell me then that I need that factor that's going to be related to occur an even number of times, and I'm going to assume 2. So I'll have the factor x plus 5, and it will be squared, again relating to that 2. Now if I come over to x equals 4, I see that one arrow goes down and one arrow goes up, which that switching behavior means that this factor, which is going to be x minus 4, is only going to occur once. And so when I'm looking at that multiplicity, it's odd, and I'm going to assume that it's 1. All right. So both of these factors, because they're resulting from vertical asymptotes, are going to go in the denominator of this function. Okay, so at this point, the hardest part is done. And so we can write the base of that function. And we know all of the variable factors at this point. We don't necessarily know the multiplicities. I've assumed that that even multiplicity is 2, not 4. I do know that I have a horizontal asymptote of y equals 2. And so that's going to dictate that the degree of the numerator is the same as the degree of the denominator. So I've chosen 2 and 1, 2 and 1, and that should match. And let's put those in. So I've got x plus 2 squared and x minus 3. And then I've got x plus 5 squared and x minus 4. So as I was saying, I can see that the degree of that numerator is 3 and the degree of the denominator is also 3, which is what I need for a horizontal asymptote of y equals 2. The last thing that that horizontal asymptote tells us, which I'll abbreviate as HA, and that is the line y equals 2, is that the ratio of leading terms would need to be 2. So the shortcut is that I'm going to have this constant factor of 2 in the numerator, essentially 2 over 1, but I'm not going to write the 1 in that denominator. The longer way of finding that constant factor would be to use a point. And this method is essential when the horizontal asymptote is y equals 0, because we don't have a numerical value to find that with. So what we would do is we would use the point, and I have one on here. I've got this point -4, 7. So any point that's easy to read and looks like an exact value, -4, 7 was the best one in this case. Let me write that out. So this is -4, 7. And so we'll use that point to find it. And the way that we do it is this. We know that 7 is going to equal some k, and then we'll put in -4 for x. So -4 plus 2 squared times -4 minus 3, and that's all over -4 plus 5 squared times -4 minus 4. So what we'll find then is that 7 equals k times -28 over -8. And if we continue solving, we'll find that k equals 2. I'm going to skip a few of those steps. But that's the other means of finding that constant factor. And that method will work regardless of what that horizontal asymptote is.